Okay, so yeah, we have our electric field in blue. The magnetic field needs to push down, so using the right-hand rule, we come up with that way. If we used Jack's way, then you take what? It's across F, Q, V, B. So what? Using the cross product interpretation of the right-hand rule, you would say like the right-hand rule or the cross product is you put your fingers along the first vector and you sweep to the second vector. But I mean, of course, that works for positive charges, so we have to actually use the left hand, right? So you have to put your fingers in the direction, right? And then you have to sweep Q, V, B. Yeah, and you have to sweep your fingers in the direction of the magnetic field because it's QV. Let me see if I can write this out, explain what I mean. We know that F is equal to QV cross B. Does that make sense? So what that means is this is the product. Your thumb is going to be the product when you do this. Anytime you do a cross product, your thumb is what's given off. Okay, like torque was F cross R, so it's the force, and then you swing, or R cross F, whatever, you swing through one to the other. Go down the radius, swing towards the force, and my thumb is the torque. When you're doing this, my fingers point down the velocity. Okay, I'm using this hand because it's the left hand. My fingers point with the velocity, and then my thumb is the force. Which way do I need the force to go? Down. Right? My thumb is the force going down. So when I sweep my fingers, everything, that means it's got to go into the board. It's a different interpretation, but I think it's actually valuable for you to understand both. I'm just going to record this again.
What's the question?
The question is, what is the magnetic field required? So we were actually being constructive there, believe it or not, because we need to know the orientation of the field as well. It's a vector, so FB has to equal FE, right? And so FB is going to be QVB. Everything's perpendicular, so that makes life easy. And then FE is going to be what? The electric field. Was it EQ, something like that? So then this takes itself out of the equation, and B is going to equal to E over the velocity. Sorry. Usually when I do that, I put a little tail on the V, or write it lowercase, which I should have written it smaller. And then, of course, E for
V over D.
For a capacitor. Jeez, God. Yeah, E is just V over D, right? E is going to be V, and this is not velocity, that's voltage, over the distance. So then this becomes V over
Bold
dV.
of velocity and not bold of voltage.
What's
Sometimes
that?
the voltage looks like a vector when you bold a V.
Oh, bold it. Okay, yeah, sorry. I was just trying to say like there. So I usually make this little tail. That's how I remember it. And so that's 200 divided by 0.01, which is going to give us 2,000, and then divided by 1 times 10 to the 7th. So 2,000 divided by that becomes 2 times 10 to the minus 3 or something? Minus 4, whatever. So is the answer around 200, whoops, 200 microtesla?
If you want to.
There you go. Oh, wait, 2 millitesla. Oh, oh, okay. I was off by 1, sorry. So it's 2,000 microtesla. I have to fix this.
Wait, sorry, really quick. How did you get the equation that the force over the V is